Hello everyone, welcome to the second video of the Python baseline tutorial series. If you haven't watched the first video and you're new to programming, please do so. There's a link in the description. And as normally, this is the GitHub page of the tutorial. And also, this is the GitHub link to the exercises for this tutorial. In this second tutorial, we will take a look at the way that Python collects elements in some collections. Especially, we'll take a look at lists, tuples, sets, and dictionaries. So let's get started with lists. A list is a variable that includes many elements. So, for example, we can create a list, name it whatever we want, like with 3 elements. Let's run it. Again, we're waiting for it to connect. This is something normal. And we also open up the variable editor to check out what list will come up when it runs. Okay, and you see that X is a list, indeed, that has 3 elements, 1, 3, and 5. A list can have multiple elements. It can also have inhomogeneous, let's say, components. So, for example, we can have a float, like 6.4, and we can also have a string. So this is again a valid list. So you can see that X has 5 items, it has some integers and a string. It can also have another list. So for example, we can have a second list in here, and if we run it again, you see that it has a 6th element. Even though the new list has 3 elements, it is considered as one element, one additional element to the list that we have added. So we can also print the list. We can see the values, and we can also print the length of the list, which we can retrieve through the len function. So if we print the length of the list, you can see that we get a number 6. We can also retrieve elements from the list starting from 0. What do I mean with that? So if we want to print the first element of the list, which is number 1, we can retrieve it using those square brackets, and we type in 0. So this is the position 0. This is position 1, 2, etc. So starting from 0, we can retrieve the elements of the list. We can also grab the third element of the list using index 2. Remember, starting from 0. So this will output 5. So this is the 0th element, 1, index 2, index 3, and index 4, as we expect, will have the string. Then if we would like, for example, to get component 4 of this list, then we would need firstly to take the list itself. So take component at index 5, like so. Here you see the list. And then if we would like to get this component from this list, so now we have retrieved the list itself, we would additionally have to get from that list component at index 1. So this would work like that. So we can have multiple indexes, one after the other, as we go deeper into nested lists within lists. So this can go on forever as long as we have lists within lists. There's also a very useful command that allows us to find specific elements. So for example, imagine that we know that this list at some point will have number 5, and if we ask for the index of this number, then by typing x.index, we actually run this function. We'll talk about functions in another tutorial, but for now it suffices to say that with this dot we access some property of X, and this property, whatever we put in here, it just retrieves the index of the component within this list. So you can see that the index of 5 is 2, which is true because this is at index 0, 1, and at index 2 we have 5. And of course we can ask, for example, let's see how we would get the string. So my name is Alice. So if we have not typed the string wrong, it will output 4. The index of the string is 4. 0, 1, 2, 3, 4. Okay, so if we try to retrieve a component that's not there, so imagine that we ask for, I don't know, 100, then we will get an error. So we'll get a value error that 100 is not in the list. So we need to pay some attention and run this command whenever we're certain that something is within the list. There are ways around that, but that's a topic of another tutorial. Okay, then finally we can assign a new component into the list. So for example, imagine that we would like to place instead of 5 some other component. So for example, if we say that x at position 2, which is where 5 is, now should be I don't know, let's say a string says new element or whatever. So now you can see that x is the same list, but instead of 5, which is at index 2, it has this component. And this way we can change the elements and assign new elements to the list. There's also a summing operation in lists. So for example, assume that we have 2 lists. So let's imagine that x is like 2, 4, 6 or whatever, and y is another list like 3, 5, 7. If we add those 2 lists, so it's like list z is x plus y. There are 2 ways that Python would add lists. One would be like to, I don't know, add its respective component. So have a new list like that's 2 plus 3, 4 plus 5, 6 plus 7. But that's not actually the way that Python treats list addition. So whenever we have a plus operation between 2 lists, what we get is the concatenation of the lists. So lists are not considered as numerical arrays. They're considered as collections of components, and plus is, as in strings, concatenation. As you can imagine, multiplication will go the same way as in strings. So if we say that w equals 3 times x, it will not multiply each component of x with the value 3. Instead, and let's also print it, it will append, concatenate x to itself 3 times. So it's like this is x, the second x, the third x. So 3 times x is like 3 concatenations of x. Of course, as you can imagine, as we cannot multiply. So if we like do u equals x times y, we cannot, there's no meaning in multiplying 2 lists, and we get this error that we cannot multiply sequence of non-integers. So let's keep this as a comment to remember it. We get this type error, and let's run it again to clear the error message. Another thing we can do is we can increase the size of the list by appending elements to it. So let's start with a new list again. So it's 1, 4, 7, and print the list 1, 4, 7. And now let's also append another component. So if we do like x dot append, so again, dot, this calls a function. We do not care about what functions are at the moment. We just say need to imagine that by doing this dot thing, we're doing something to x. So let's do something to x that is append another component, which is like, I don't know, 1.4. So this, if we print the x now, you will see that x, the second iteration, will have 1.4 at the end. So now let's imagine that we have a second list. So we have y equals, I don't know, 3, 6, 8. Okay. Now, what happens if we append the list y to x? So if we say x append the new list y, what will happen is that the y list will get appended as an additional component. So you see that here what we have done is we have inserted one new element, which is a list. But what if we didn't want that? So what if we just wanted to concatenate those elements directly to x? Well, as you can imagine, there are two ways around it. So if we would not do that, and let's comment that out, because what this does, it just appends one new component, which is the list, the entire list. And imagine that we do not do that, but instead we do like x equals what it was before. So x, remember at this point, is 1, 4, 7, and 1.7, that 1.4 that has been appended. And we want to concatenate this list. As you can imagine, x equals what it was plus y. So this way, what we do, we just concatenate this new list. This can be done with another way as well. So we can do like, if we do not go this way, so if we do not use the plus sign, we can do it another way, like x dot extend y. This is a similar way, this is a similar way of doing whatever we did earlier with the plus sign. So if we extend instead of append, we get the similar result. And just to make the tutorial less confusing, let's also say that, let's put that here, and just as a comment, add that we can achieve the same result using the plus sign. Okay, so another thing that we can do, and I hope this is not confusing, instead of writing down this in this form, so that x plus equals y. So what we have done actually here is we have, instead of writing x equals what it was plus y, it's some kind of a shorthand for saying that x plus equals means what it was plus what's on the right side of this operator combination. So this way we get exactly the same effect. So those three ways are ways of extending a list. So we can say that this is number one. number 2, which is actually the same as number 3, but let's keep it as a separate way of doing so. We can also remove element from a position. So now x, and let's keep, for example, the first way. So now x is this list, and let's say that we need to remove 1.4, which is at position 0, 1, 2, 3. So let's remove element from position 3. So if we do x pop 3, then the new list should be the list that it was without 1.4. So this has removed component index 3. Another thing we can do is we can actually remove an element, a specific component by name. So for example, in this list, let's say that we want to get rid of 4. We don't know where it is, we don't care where it is. We just know that there is a 4 in there and we need to remove it. So if we do like x dot remove component 4, then we get rid of 4 regardless of where it is. Okay, so another interesting object in Python is range. We will deal with ranges afterwards when we do loops in another tutorial, but for now on, let's see how we can create quickly a list with using range. So range creates an object, let's say for example range 10, r equals range 10. You can see that r is of type range and has no further information rather than that it's a range. But what we can do, if we print the range r, we can transform it into a list. For example, let's say that x equals list. You remember that we can interchange between different types using some commands in Python. So if we just take the list form of r, you can see that we get a list that starts from 0 integer values up to 9, so not including 10, up to 10, not including 10. We can also do other tricks. So for example, we can start from 2 and go up to 10. So that's the same thing, but instead of starting from 0, we now identified that, defined that we start from 2. And we can also change the step. So jump 3 and and go to 10. So it's 2 plus 3, it's 5 plus 3, it's 8 plus 3, it would be 11. So we would surpass 10, so it stops there. So this actually belongs here. This is a list from range. And let's go through a very short tutorial for the for. So in Python we can do like for r in for let's say x in range, let's say 2, 10, 3, whatever, print x. We're gonna go through details for this tutorial, but now let's see this very short tutorial about how we can use for, how range is relevant. You can see that here x takes each value within range. So this is a normal way that we would use range in Python. If we wanted to go through some numbers and do whatever we do here, we might need to add them somewhere or retrieve some component of a list or whatever. So this is a very short tutorial for that. Now let's move on to tuples. Tuples are as lists, but they are immutable, so you cannot change things in there. To start a tuple, you just need to, let's say t equals, now we use parentheses 1, 3, 5, and if we print t, it just appears with parentheses instead of square brackets, so t is a tuple now, not a list. We can do the index thing. So for example, if we do like t dot index 3 and print that actually. As in lists, what this function, this index function will do, it will inform us about where in the tuple number 3 is. So it's at index 1, indeed, this is index 0, this is index 1. We can also get the length of a tuple, as in lists. And if, for example, we had a list that's like, I don't know, 4, 3, 6, 7. So now we have two occurrences of 3, and we can just ask the list to count, the tuple to count how many elements we have how many times we have number 3 in the tuple, which is twice, once here and once here. Again, we can have whatever we want in a tuple. So this is a valid tuple. It has whatever it needs. It can also have nested tuples within it, lists, whatever. But append does not work. So if we try to, as in lists, append at the end a new component, then this would not work. Tuple object has no attribute append. So let's keep this error. And also we cannot change. So if we want to, in the first element of the tuple, so at index 0, change the value, then we cannot. It does not support item assignment. So let's clear those errors and keep that in mind, that tuple is immutable, which means that we cannot change or append anything in the tuple. So sets are another very interesting component in Python. You can see watch whatever tutorial you want. This is a very nice tutorial, for example, in sets. It has very concise information. A set is initialized with curly brackets, like so. So if we say that this is a set, and let's intentionally duplicate the occurrence of 3. So if we print this set, you can see that it only has one occurrence of 3. So duplicates are not allowed, because a set is like a set of a collection of separate components. Again, as in tuples, we cannot append, we cannot change a component, and well, sets are not subscriptable, which means that they are not ordered. So we don't have there is no notion of a first, second, and third element in them. So there's no point in doing subscripts. But sets are very useful for special operations. So for example, like union, intersection, difference, and some shortcut versions of those operations. So for example, if we have set 1, which is like, I don't know, 1, 2, 3, 4, 5, 6, and set 2, which is like 4, 5, 6, 7, 8, 9, okay, those two sets, we can have the union of the two sets. So we can have a new set, let's say S equals S1 dot union. So from S1 get the union with S2. So this will produce a new set that has all the components of S1 and S2. So if we print that out, you can see that S has all the components of S1 and S2, and you can see that there are no duplicates. So it has 4, 5, and 6, and since it's common, it just uses those things once. Similarly, we can have a new set that's the intersection of between S1 and S2. So, and let's also print it. In this case, you can see that it has only the common components. So it's a very so a set is a very convenient way to deal with such information, what things are in common, etc. and it also has the difference. So let's go through that as well. S1 dot difference with S2. So if we now print S, you will see that it has whatever S1 has, and by removing, this is the difference, whatever S2 has. And we can do it also with a shorthand. So for example, S equals S1 minus S2. So again, this would be the same as the one we've typed above, but it's another way of writing it down with a shorthand. Also, you can see that we get a different result if we do it the other way around. So this is what S2 has if we remove whatever S1 has. So it has the components that are unique to S2. And also we can check if one is a subset of another. So let's check, for example, if S1 is a subset of S2, which is not. But now the way that S is at this point, so S now is like 8, 9, 7. You can see that the order does not really matter. We can ask whether S is a subset of S2, which indeed it is, because it has S2 is like, if you remember, all this, so it includes 7, 8, 9, and S at this point of the code is like 8, 9, 7, which is like 8, 9, it's 8, 7, 8, 9. So it's a subset of S2, which is true. And there's also the symmetric difference, which is like, this is not, difference is not symmetric, because you've seen that S2 minus S1 is different from S1 minus S2. So if we do the symmetric difference, so we say that S equals S1 symmetric difference with S2 and print S, you can see that this is whatever both sets have uniquely and not in common. So 4, 5, 6 is common to both sets, so the symmetric difference will not have the common components. So this is symmetric because it doesn't matter whichever one you put first, the result will be the same, either S1 or S2. Of course, we can also interchange between types. So let's see what S is at this point. Okay, it's this symmetric difference thing, and we can take a list out of it. So we can say that X equals list of S, and if we print X, you will see that it's a list. We can also get a tuple out of the set of S, for example, okay, and print it just to see how it works. Great. And as you can imagine, if we have another list, let's say 1, 2, 3, 4, 3, 4, 5, or whatever, you see that we have a double occurrence of 3 and 4. So if we make a set out of Y, you'll see that it will preserve the property of the set, so 3 and 4 will only occur once. So this is a good way, for example, to remove duplicates. If we want to remove duplicates, we can go from a list to a set and then possibly back to a list that does not have the duplicates. So those transitions would help for some tricks. Then we can have max, spin, and sort. So those are functions. Let's do it with lists. So if we have like a list, let's mix that up a bit. Okay, so this is a list, and we can get the maximum value of this list, which is 12. We can also get similarly the minimum value of the list, which is like 2. And we can also get a sorted version of the list. So if we do like x.sort, then this list becomes sorted. So if we now print x, you will see that we have all elements ordered. Okay, so now let's talk about dictionaries. Dictionaries are collections of elements that have some key and some value. Let's get an example. So for example, we have a dictionary D. We initialize it with curly brackets, but it's not like a set. We now have to give two components. So for example, we can have a field that is like name, which is like, I don't know, Alice. We can have another field that's like age. Let's say the age is like, I don't know, 20 or whatever. And let's say that we have another field that is, I don't know, height. So this could be like, I don't know, 1.7 meters or whatever. Okay, so now if we print D, we see that we have a collection of components that are characterized by a value, by key, sorry, and a value. A key and a value. So we have a column here, key and value, the opposite sides. And we can initialize a new dictionary. For example, let's call it, I don't know, G, with as an empty dictionary. So if we have an empty dictionary like so, you can see that it's empty, and we will see how we'll fill it up. And those dictionaries, both these dictionaries have key and value components. So let's start with D. So if we get the keys of D, it's like D dot keys, that's a function. So if we get the keys of D and print them, you see that the type of K, here it is dict keys. So we can see that somewhere in here it's the list of keys. So a usual way of getting a list of keys is like we can directly get the list of keys. So now K is actually a list that we can manipulate as a list. Similarly, we can take the values of a dictionary and we can, let's go for example to values first. So this way we get the values. Here we are. It's again an object of type dict values. So to go to list directly, we can do that and get a list that only has the values. So you see that the keys are the left side for the columns, and now the values are the right side. So keys and values. And what dictionaries allow us to do is we can retrieve an element not by the index, not by defining the position, but by defining the key. So for example, if we're interested in the age of D, we can do it like so. So if we just print the age of D, we can use the square brackets as we would do with lists, but instead of adding a number, instead of giving a number, we give the string or whatever key we have. It's not necessary to have a string as a key. So you can see that the age is 20, the name is Alice, and we can also add information. If we do, for example, if we want to add to this Alice person of age 20 and 1.7, for example, we want to add like favorite foods. So D, we want to add favorite foods, and we want to add the list, let's say, with, I don't know, pizza or I don't know what else, spaghetti, how you write it, I don't know, or whatever other foods. So if we now print D, you can see that we have also somehow appended the new field, the new key value pair, which is like favorite foods as a key and pizza and spaghetti as a value. So this is a good way of starting with an empty dictionary as shown above. So G is empty, it starts empty, and we start adding things on the fly. So you can say that G, I don't know, like brand equals, I don't know, Ford or whatever, and G, I don't know, model is like, I don't know, Fiesta or whatever, and yeah, and so on. So if we print G, it now has some information that we have added afterwards, which is something that we might need to do in our program. And finally, we can delete information from a dictionary by deleting the relevant key. So for example, if we're not still interested in keeping, for example, the height of in D, we can just use this function and delete height information. So now D will be as it was, but you can see that the height information has been removed. Up here we have height, but we don't still have height. Okay, so this is the end of the second tutorial. I remind you that you can go into the GitHub on the GitHub page and do the exercises. And until the next tutorial, bye for now.